going to talk about the Log4j exploit, SVE 2021-44228. I'm calling it the exploit of exploits. So what is Log4j? Log4j is an open source logging framework that allows software developers to log various data within their applications and is part of the Apache logging service. Basically, a textbook definition that I was able to look up. And I mean, it could be used for debugging while in development, receiving bug and crash reports once the app is live, logging just basic use of a system, people logging in, logging out, keeping track of chats and video games. Kind of really just depends on its need. Logs are pretty important. So a brief timeline about the Log4j API. Log4j was first released January 8, 2001 as part of the Apache software logging services. And it has performed its intended tasks well until recently. And there is some parts of the exploit that are necessary, so I'm going to go into a little bit about those right now, but we'll cover those in later slides. So in 2013, there was an API called JNDI lookup that was added into the mix, and like I said, we'll go over that in just a moment. But this is when the problem was introduced, but it wasn't until 2001 that it really became an issue. But even before it became an issue, in 2016, Black Hat had a discussion over JNDI and was talking about how users could pass pretty much whatever they wanted through that logging system without it being checked. And so Black Hat was saying, JNDI, you shouldn't allow anything to be passed through there that you don't know what's being passed. And well, nothing ever really got fixed, and it turns out that JNDI is the reason the exploit for Log4j actually works. And from what I've been able to tell, this is the biggest overlooked security flaw that we know of to date. So what is the vulnerability? What versions are affected by it? So the versions that were initially affected by the exploit was version 2 through 2.14.1. It is now known that there's bypasses even around those fixes until version 2.17. And like I was saying, so this vulnerability allows users to input to be passed to a server and actions performed without checks on what the input was. And this was the warning that was given by Black Hat in 2016. They had said that an unknown user supplied data should not be trusted and passed to the JNDI lookup. This flaw was indeed a remote code execution and could be done very easily with that one line of code there in that third bullet point. It's basically a boilerplate code of how it can be done. We'll go into that in just a little bit. And this service, the Log4j API, is used by countless companies, and I just named a few here: AWS, IBM, Cloudflare, big names that I'm sure we all know what they are. So why is it so dangerous? Back to that one-liner I was talking about on the slide before. It's really easy to perform. and there's many exploits that are already up on GitHub, so that makes it pretty easy. So, and it's not something that's really easily patched because it's running in so many places with so many different configurations. So just pushing out a patch might not necessarily work. And there's just not a bunch of security to hop through. I'll demonstrate that, or not demonstrate, but I'll show you a video in just a moment about just how easy it is. I mean, this can be used in drive-by attacks to attack random servers until the attacker finds a server that's actually vulnerable to this attack. And I mean, it takes and processes user input without sanitation. And because of this, the CVSS rating was given a 10, and which is the highest critical rating that can be given. So this is basically a visual of how and what's happening here. So it's coming in, the attacker sends a request, the Log4j application picks it up, runs it through the JNDI interface, and through the JNDI interface it calls back to the attacker's hosted LDAP server and sends payload back to the server, which downloads it and runs it. Go into this a little bit more in a few slides. We got to go over a few things first. So LDAP, I just mentioned the LDAP server in the previous slide. Give you a little understanding of basically what LDAPs are for. So there's a few components here, and it's the first piece of the puzzle, the LDAP. This is an API that allows for users on a system to only have to log in once, but have access to many files on a server, and these LDAP servers can be created by nearly anyone with the technical know-how. And so this is what an attacker is going to set up on their own computer or whatnot, and where they're going to host the malicious files. Next part is JNDI. This is the API that facilitates the communication between LDAP and the Log4j API, and that's basically what JNDI is used for in this purpose. So performing the exploit and popping some calculators. So like I was saying, the attacker could just do drive-by attacks on random servers with something just like this that allows for detecting the vulnerability but does not lead to any code execution, so it wouldn't necessarily raise any flags that, you know, these were coming through. And then after that, after they find a vulnerable server, they're going to send a malicious request to the server. This could be done by sending a message in chat server or a crafted HTTP header. And then, so I did find a video of this of somebody doing this in Minecraft, and it's just a short little video that we'll watch real quick. So there he's typing in a chat. He's clearing the old calculator. Now there you go. That's basically, oops, what I was talking about there. There is that syntax. This is his IP address to the server he has set up, his port, and the name of the malicious file is just A. That's it. Popping calculators. So then what was happening in there is, the target server logs the request with log4j. Log4j passes the string to JNDI. JNDI queries the malicious LDAP server, and LDAP responds with the malicious Java class created by the attacker, and the target server now downloads and runs the malicious payload. Calculators, baby. Everybody gets a calculator. So this is just kind of a little diagram of everything I just explained. Sends the user agent, log4j server, log4j queries LDAP, and boom, boom, back around. So mitigation of the log4j exploit. So not all applications using the log4j API are going to be vulnerable. So if somebody wanted to test and whatnot, and they didn't really know a whole lot about technology, this is a really easy test that was created by Huntress Labs. It requires just downloading and running one line of code, and yeah, it'll let you know. So applications that aren't going to be vulnerable are applications that have no JNDI lookup functionality. The best fixes for this right now is to upgrade to versions 2.17 or newer. The current release is 2.18. For versions 2.1 and later, if you aren't able to upgrade or for whatever reason, you can go in and disable JNDI lookups. But there is a bypass to this, but it's still better than not updating at all. So you could do that for a single application, or you could go into your etc environment file and add this single line, and this will ensure that anything running Java on the system will not use JNDI lookups. And then the third and likely worse solution would be to just try and remove the JNDI lookup class. So you can run this find, and it will do a search from the root directory wherever you start the search from, and it will recursively find all your log4j core jar files and remove all the JND lookup classes. This won't necessarily fix the whole problem, because there may be instances where the JavaScript is reaching out remotely to find that JND, to use JND. And that's basically that. I hope you were able to learn something. If you'd like to visit any of the resources that I got this information from, this is a list of the resources that I did use. Thank you so much.